Meet James Rodriguez, a genius guitarist. When he goes up on stage, he draws people from all over the world, and the crowd go crazy at every note played. Well, at least in his most ambitious dreams. But hardworking as a boy is, I believe he can achieve those dreams in the future. What is it, James? Your amplifier broke and now you can't play the guitar? That's a problem. Why don't you buy another? You have no money to buy another? I have a solution for you. A homemade mini amplifier, cheap and easy to build, using only a 9 volts power supply and some electronic components. You sure are curious, James. You wanna know how does such small amplifier works? I will explain it to you then. But first, let's check inside the amplifier box. When the guitar strings are played, their vibrations are sensed and transformed into electrical signals, and then transferred to the circuit. This signal is an input signal to the circuit, entering the triangle. The name of this triangle is operational amplifier, and as its own name says, its main function is amplification. In reality, it looks more like a black box. James's op-amp is the model LM386. Let's check what's inside the mini black box. In here, we see a lot of transistors, the most important component of op-amps. Transistors are semiconductors of 3 terminals, where a signal can be input through one and output through other, amplified or not. If the transistor is in the correct operating point, condition for it to work as wanted. The transistors type NPN and PNP are used in this op-amp, and its terminals are base, emitter, and collector. The first transistor passed by the signal is Q3, a PNP. The signal enters in the base and exits through the emitter, and no gains provided. That means the signal will come out the same way it came in. But this stage is very important to set the next stage operating point. Its configuration is called common emitter. Then, the signal passes through a grouping of transistors called long-tailed differential pair, and in here we can set how much the signal will be amplified, the gain. Connecting these 2 points, we can set the amplification to its maximum. An important feature of the long-tail differential pair is its capabilities of removing noise applied by the power supply. Imagine if after a long time of use, the 9 volts battery starts to fail and input some signals in the op-amp. Those signals would interfere with ours, and that's no good. Fortunately, these signals are eliminated by the differential pair, a true savior. The signal is output through the collector of Q4, still no gain, and then enters the base of Q7, where it comes out from the collector, amplified. Then we go to the last stage of the op-amp, also a grouping of transistors, named push-pull configuration, is responsible for preparing our signal to be transformed into sound by the loudspeaker. Q8 take turns with Q9 and Q10 in conducting the signal off from the op-amp. Half of the signal is conducted by Q8 and the other half conducted by the pair Q9 and Q10. This pairing is necessary because the PNP Q9 would not be efficient in the task of preparing the signal as the NPN Q8, and 2 NPNs can't form a push-pull configuration, so Q10 is connected to Q9 to improve its efficiency. The diodes, these arrow-like components, are used to remove distortion caused by the transition between conduction time of Q8 and Q9-Q10. Finally, the electrical signal is output from the op-amp and input in the loudspeaker, where it is then transformed into the sounds you hear when playing. To the loudspeaker then. The main components of a loudspeaker are a permanent magnet, an electromagnet, and a cone, made of either paper or plastic, and in some occasions, a not heavy metal. The electromagnet is a coil, a piece of iron wrapped by a wire, magnetized only when the loudspeaker is put into work. When the loudspeaker is not working, springs and dampers are responsible for maintaining the cone in its right location, and they also help in controlling the vibrations. When the signal is applied in the loudspeaker, the coil sometimes attracts and sometimes repels the permanent magnet, moving it forward and backwards, pulling and pushing the cone, and the cone's movement or its vibrations are responsible for pumping sounds into the air. Way to go, boy! Now that you have built your amplifier, you can practice again and strive to be the best. And I do hope you remember me when you are famous.